In this lesson we're going to look at some properties of logarithms, four specific ones in this lesson, that will allow us a way to rewrite logs that maybe will make solving a logarithmic equation a bit easier for us depending on the situation. First property we want to look at is this one. It says that if we have a log base b of x times y, we can make the argument into a product. Then we can separate those into two separate logs. Log base b of x, the first number in the argument, plus the log base b of y. This will give us maybe a way to solve a problem. For example, if I know log of 4, and remember that's a common log. If I don't write a base there, it means base 10, plus the log of 3. If I know the log of those two things, then I will be able to find also the log of 4 times 3, which of course is the log of 12. So if I know the log base 10 of 4 and the log base 10 of 3, then I also know the log base 10 of 12 because I can apply that property. And of course I could apply it in reverse also, like this. If I know something is the log base 2 of 12, then I know I could also rewrite that, for example, as the log base 2 of 3 plus the log base 2 of 4, because 3 times 4 is 12. My second property applies to division, and as it probably would come as no surprise to you, you can subtract the two logs so that the log base x divided by y, base b of x divided by y, is equal to the log base b of x minus the log base b of y. Now you may have noticed that both of these that we've looked at so far, they're derived from the laws of exponents, which basically if you have the same base with exponents and you're multiplying, remember that we add exponents. If you have the same base with exponents and you're dividing, you subtract them. So this should come as no surprise since the log is the inverse of the exponential function. An example of this would be something like this. If we had the log of 100 minus the log of 20, that of course would equal the log of 5, 100 divided by 20. And again, I'm using a common base, which means that's base 10. So that can be a very useful function for you also, to be able to rewrite logs like that using subtraction. And it works in reverse also. Let's look at a third property. In this property, if we have the log base b of some number raised to a power, then we're allowed to take that power outside of the log to the front and multiply it by the log base b of x. This is a very useful function for us. For example, if we have log base 3 of 9, and then that is raised to some power like 4, instead of taking the log base 3 of 9 to the 4th power, we're allowed to bring the 4 to the front and simply multiply 4 times the log base 3 of 9. And we could actually, I guess, go ahead and solve this problem because we should know that the log base 3 of 9 is what number is 3, what power of 3 is equal to 9, and that power is 2. So we know the log base 3 of 9 is 2. So this should equal 8. We actually could get a solution to that one by finding that log, by rewriting 3 to what power is 9, and it's 2 in this case. The last property we want to look at in this lesson is this one, and it actually is the same property used again. But if you think about this one, if we have a log of the same base and argument. The base is b, the argument is b. Then the solution to that log will always be whatever power x is right here. So if we have a log base 3 of 3 raised to the second power, then it's always going to equal 2 because that's what the power is. Another example of this, and you have to be careful with this one, it's easy to miss. If we have the log of 10 raised to the third power, this one may not be as obvious because again we're using common log, but that implies base 10. We just don't have to write it. The bases are the same, therefore the log is equal to 3 in this case. Any log that has the same base and argument that doesn't have a power written in, remember that power is assumed to be 1, those will always just equal to 1. So that's actually a pretty simple property to use, but can be very useful in solving problems for us. Let's take a quick look at one example of how this might be used to solve a problem here. I'm going to write in a problem here that we're going to be given a couple of things. For example, what if we know that the log base 2, or pardon me, the log base 10 of 2 is equal to 0.3. It's something close to that. Would I have a way of finding then the log of 4 base 10? Well, one thing that I know about properties is that 4 is simply the log of 2 times 2. And since I know that the log of 2 times 2 can be separated using a property into the log of 2 plus the log of 2, using the property that says multiplication inside the function becomes addition outside, that means that log base 2 of 2 is 0.3, and the log base 2 of this one is also 0.3. So the log base, I keep saying the log base 2, the log of 2 plus the log of 2 is 0.3 and 0.3. Therefore the log of 4 must be 0.6, 0.3 plus 0.3. So by using the properties, we took something we were given, the log base 10 of 2, or the common log of 2, is equal to 0.3, and we were able to find another answer for another number that was simply, in this case, a multiple of 2. So if we were given several logs, we could apply those properties in different ways to solve problems like that. And that can be a very useful thing to be able to do. So we can use the properties to rewrite or simplify expressions of logs. We can use them to actually solve problems whenever we know the values of certain logs. And so we can do that with several kinds of problems. I want to do one more here. I want to rewrite a log here as a single expression. I'm going to start out with this one just like this. Log base 4 of, and we're going to do 6x plus 4 minus the log base 4 of 2. And what we'd like to do is rewrite this as a single expression. Now let's apply the rule we know, or the property we know. And that is that subtraction in this case becomes division. So we do 6x plus 4 divided by 2, and that would be equal to the log base 4 of 6 divided by 2 is 3x, 4 divided by 2 is 2. And we have simplified that log into a single expression.